Hey everybody, welcome back to Physical Science after the long weekend. Hopefully you had a great Thanksgiving with your family and friends. And possibly neighbors. And maybe your neighbors' friends too. Or your neighbors' families as well. Hopefully you had a good weekend, whoever you were with. Anyway, chemical bonding. So, this is the next chapter in our book. And chemical bonding, look, I'm starting out with electrons and chemical bonding. Look, chemical bonding is the joining of atoms by the electrons to form new substances. Okay, so these are the key words. Chemical bonding, electrons, new substances. Okay, so a chemical bond then is the noun of the verb that we just talked about. A chemical bond is the force that holds atoms together in a compound. Remember, a force is what? A push or a pull, right? Well, if these are holding them together, then this is going to be a pull kind of force. Do you agree? Okay, so the chemical bond is the force that holds the atoms together in a compound. Okay, kind of the key words here are chemical bond, force, but look, it says atoms in a compound. So when you have atoms together, you have a compound. Okay. Okay, look at this. A new substance has new properties, which you can see on page 145. Everyone turn to your book on page 145, you'll see a good example of this. But look at this, even for example, sodium, which sodium we know is a metal, right? A very reactive metal. We'll see that later on. Plus chlorine, which is a poisonous gas, a green poisonous gas. Together they form something that people use for preservatives for years and years and years and years. Still do, really. Or you put it on your potatoes or corn or whatever you want to taste a little bit better. So, I mean, could you eat sodium? No. Could you eat chlorine gas? No way. Could you eat sodium chloride? Yes, and everyone does, and everyone likes it. Too much in America. Hey. Number 3. Elements will react until they have an octet of valence electrons. Okay, so an octet. Now, is that always true? Elements will react until they have an octet of valence electrons. Those are the key words. The key words are elements react, octet of valence electrons. Valence is just the highest energy level, right? But there is an exception to this rule. What is it called? The duet rule. Some elements will only react until they have 2 in their outer level, which would be hydrogen, helium, lithium, beryllium, because they don't have that many electrons in the first place. Okay, the question was, what is a noble gas electron configuration? Well, notice, the noble gases. Okay, so where are the noble gases, first of all? Here's the noble gases right here. Right? These are the nobles. Right here. So you got helium, neon, argon, krypton, xenon, radon. They all have octets in their outer level except for neon. Neon does, helium. Helium doesn't because it only has 2 electrons. Okay, so that, a noble gas electron configuration, remember we said the noble gases don't react? Because they're noble? Well, that's where the octet rule comes from. Okay, so when these elements react, until they get an octet. Now I got to tell you one thing about this. They don't actually get an octet necessarily. They might be sharing. So there's going to be 2 different kinds of reactions we talk about, or compounds that we talk about, ionic and covalent. Like co-pilot, co-producer, that means they're sharing in the, co-coaching, they're sharing your responsibilities, right? So what do you think covalent means? Sharing valence electrons. That's how easy it is. Yeah, very good. And then ionic, we'll talk about a little bit later, that's when we use ions and different charged particles to come together with the force of electricity. But for now, compound is a substance made of two or more elements in a regular proportion. So what that means by regular is I have the same proportion, like if I find water here or find water on a different planet. But what if I find water outside on the parking lot? It's going to have the same proportion. It's always going to be H2O. Or if I have sodium chloride, it's always going to be in this proportion, NaCl. Doesn't matter where I find it. And that's the definition of a compound. If I have a different proportion, then it's a different compound. Okay. So, you could look on page 146 and 147, and they'll talk about some different compounds. Okay. So so atomic stability, just for a definition here. Atomic stability is when an atom has an octet. We already talked about that. But chemical stability then, chemical stability is when an atom or compound will not react. And that will be because they are following what's called the octet rule. So you should be putting these two things together. Octet rule, 8 electrons in the valence shell, noble gases. So elements will react until they fulfill what's called the octet rule, which we'll explain a little bit more here in a little bit. Okay, which is more reactive is the question I want to ask you right now. Is it magnesium or sodium, bromine or krypton, nitrogen or fluorine? Okay, so write those down right now, and then we'll look at the periodic chart together, and we'll figure out which is more reactive. Magnesium or sodium? So out of those two, which is more reactive?
Magnesium.
Yeah, magnesium or sodium?
Wait, sodium.
Bromine or krypton? Nitrogen or fluorine? So write those down in your notes. Then we're going to look at the periodic chart together, and we're going to figure out which one actually is more reactive. Okay, do you have them written down? Okay, what were the first two? The first two were magnesium. Magnesium and sodium. So they're both right here. Do you see those? Magnesium and sodium. Okay. Well, let's look at it this way. Okay. Now, could you quickly tell me what the valence electrons are in a sodium atom?
1.
1?
Right?
Okay, so we have magnesium and sodium. What is the valence electrons for magnesium?
2.
2, right? And how about for sodium? 1. Okay. Now, the question is, which one is closer to an octet? Which one? Is it Mg or is it sodium? Okay, now this is kind of the trick. You got to get this, okay? Because if you look at this, okay, we would have to go, for magnesium, if we're going to go this way, we would have to go all the way over here to get to an octet. Do you agree?
Yeah.
So it'd be like adding 6 electrons, right? Okay, but the thing is with these, you don't always have to add, you can also take away. So if I took away 2 from magnesium, then I would end up having the same look with electron and valence shells as the neon gas. Do you see what I'm saying? So, as an atom, would it be easier to take on 6 electrons or give off 2 to achieve this octet?
Give off 2.
Give off 2, right? Any questions about that? So everyone agrees that giving away 2 would be easier than taking on 6. So that is the way that magnesium is actually going to react then. It's going to end up giving away 2 electrons, because then its shell backs down, not magnesium, not sodium, but it backs down to finally this neon electron configuration. So now it has an octet if it gives away 2. Here's the next question.
Wait, so is it Mg?
Well, the next question is, sodium, how many does that have to take on or give off? Give off 1 to get here, right? And that's what it would do. It would give off 1 to react, which is, much less work than taking on 7. Is it easier to give off 1 or to give off 2?
1.
Which one's more reactive?
2.
Okay, so the sodium then is the final answer. That's the most reactive, because all it has to do is give off just 1 electron. That's easier to do than give off 2, which is what magnesium would have to do. So for our first sets, we would say that sodium is more reactive, because it's closer to the octet. Okay, what were the next 2 that we talked about?
Bromine and krypton.
Okay, so we have bromine,
Krypton.
which is over here, right?
Yep.
How many valence electrons does bromine have?
7.
7. Good, you guys are good. And then krypton, which is right next to it,
8.
which one's more reactive?
Because it's already there.
Hold on. So think of reactive as mingling with another atom. Which one's going to mingle or react or get together with another atom? Bromine or krypton?
Bromine.
Bromine, because krypton already has,
all of its family members there.
yeah, krypton already has an octet, and so it will not. Okay, so the next 2 then, we're talking about nitrogen, which is right here. How many electrons does nitrogen have?
5.
5. How about fluorine? How many does it have?
7.
Okay. Now, are these going to take on electrons or give them away, do you think?
Take on.
They will take on electrons because they're almost there already. It'd be much easier to take on 1 for fluorine than to give away 7 to get to an octet, right? So which one is more reactive in this case? Fluorine is more reactive because it's easier to take on 1 than to take on 3. Okay, good job. You guys passed that test. And finally, we have definition, chemical formula. It tells information about a compound. Chemical formula tells information about a compound. Okay. So that's the end of the notes today, but for now, what I want you to do is this assignment. Explain how each of the following are used in a chemical formula. Give examples for each. Symbol, subscript, superscript, and parentheses. You got 10 minutes to do that.